If I were to ask you this question about what's more impressive, scoring a 25 on a test whose average in the class was a 22, or scoring a 64 on a test whose average score was a 58. Which of those two things would you consider to be more impressive? Now, I'd like you to pause the video and think about that for a second, and then start back up. And as you're thinking about it, what you may think about is, all right, well, what's some other information that might be nice to know before answering this question? So go ahead and pause the video now. All right, after you had a chance to kind of think about it, you may have thought about some other information that would be nice to know for this question. Maybe you wanted to know on that first or the second test, well, how many points were possible on that test? Was getting a 25 on the test when the average was a 22? Was the test out of 25? That would be really good. Was the 64 when the average was a 58? Was that a 64%? Well, maybe that's not so good, even though the average was lower than that. So knowing how many points were possible, that might be something you want to know. Maybe you want to know how many people were in the class. If you were looking at 2 or 3 classes combined, then the average of a 22 and you scoring a 25, maybe you consider that more impressive than if you had a small number. Maybe you had a class of 10 or 12. So there may be different questions that you would have to know in order to really decide which one's more impressive. Well, what we're going to look at is another way that we can compare a score in relative terms. We talked about percentiles last week. Now we're going to look at another way that we can do that. The other way we're going to look at is we're going to look at what's considered to be a z-score. And we're going to talk about standardizing with z-scores. First of all, standardizing in general gives us a way to compare with respect to the rest of the group. You do standardized tests all the time, the ACT, the SAT. When you did I-STEP, all those were standardized tests. They set up a standard and they did a comparison between, for instance, the ACT is comparing students in Indiana to students in California to students all over the country at a standard rate. Well, what a z-score is? A z-score is the exact number of standard deviations a data value is above or below the mean. So when we do z-scores, we're using standard deviation as a measuring stick. Now, that sounds a little bit confusing when you look at that definition. So here might be a way to think about a z-score. If the mean height of a sophomore boy is 68 inches and the standard deviation is 2 inches, then we would say someone who is 70 inches tall has a z-score of +1 or +1 because they were 1 standard deviation above the mean. Versus someone who's 64 inches tall would have a z-score of -2 because they were 2 standard deviations below the average. So the average was 68. They were a total of 4 inches below that, but that was 2 sets of 2-inch standard deviations. So a standard deviation, or I'm sorry, a z-score can be positive or negative depending on if you were above or below the mean. Well, sometimes we don't have a standard deviation or a z-score that's exactly 1 or 2 or 3 standard deviations away. So we're going to use a formula to help us when that happens. So we're going to use this formula here for z-scores. And so the z-score can be found by looking at, first of all, x, which is just the data value, minus x bar, which we already know is the mean, divided by s, or it could be sx, but that's the standard deviation. So in order to find the z-score, we need to know those 3 things. We need the data value, we need the mean, and we need the standard deviation. All right, well, let's say that we were told for that first test that I gave you the example of, the one where you got a 25 and the average was a 22. If the standard deviation on that was 1.7, we can find the z-score. So the z-score would be the 25 we got minus the 22 that we had for an average divided by the standard deviation of 1.7. So if I do 25 minus 22, I divide by 1.7, I get a z-score of 1.76. And we always go z-scores to 2 decimal places. The second test, they said, had a standard deviation of 3.3. But I've already forgot what the scores were on that. So we got a 64, the average was a 58. So I'm going to find the z-score by taking my 64 minus the average of the 58 and now dividing it by that standard deviation of 3.3. So when I do that division, I'm going to take 6 divided by 3.3 and I get 1.82. So which one was more impressive? Well, the one that would be more impressive would be the one that has the larger z-score. So the one that was most impressive was this one here because the z-score was 1.82. And that tells me it was 1.82 standard deviations above the mean or the average. So let's look at another z-score example. So again, z-scores are used to compare relative performance. In other words, how it compares to the rest of the data set. So let's say this was our situation. We had Jackie that was going to try to join Mensa. Mensa is the largest high IQ society, and it accepts one of two things, either SAT scores or IQ scores. So assume the mean for the SAT score was 1,500. It had a standard deviation of 300, and Jackie scored a combined 2,070. Versus Maria, who took the traditional IQ test, she scored a 129, and then on that test, the mean was 100, and the standard deviation was 15. Well, here's what we're going to try to figure out using z-scores. According to the tests, at least, who would be considered more intelligent? So let's start out with Jackie, the one that took the SAT. So Jackie's z-score would be the 1,500 that she scored, or I'm sorry, she scored a 2,070 minus the mean or the average of 1,500 divided by the standard deviation of 300. So if I do that, if I do 2070 minus 1,500, and I would practice punching it in, making sure you're getting the right values. Divided by 300 equals 1.9. So 1.90 is her z-score. Versus Maria. Maria took the IQ test. On that test, she scored a 129. The mean was 100. The standard deviation was 15. So we're going to end up taking 29 divided by 15. And so her z-score was 1.93. So if we use z-scores as a way to compare, we find out that according to these tests at least, Maria was more intelligent, or she had a better performance on her test compared to Jackie, because she was 1.93 standard deviations away from the mean, above the mean. Jackie was only 1.90 standard deviations above the mean. So z-scores are going to be a way that we can come up with a relative comparison between test scores. Now, what we're going to do in the next chapter is kind of tie z-scores together with percentiles. So that's why this section is important, because it's really a good lead in to some future concepts that we're going to deal with.